Hey guys, it's Crypto Joji, and today I'll be showing you how I try to stay up to date and learn new things and increase my knowledge, and so that if I find the same application, the same type of attack, I can easily recall it and I can easily be able to exploit it. Hence, I can achieve critical bugs and I can hack applications greater. With this methodology, I'm able to understand the application than the developer, and it's just a simple thing I do. So the first thing I did was I bought a cheap old HP desktop and installed Proxmox. For those who don't know, Proxmox is a software that is used for virtualization. To access it, I just go to that is the IP that you set up during the install process, and don't worry about my password. It's just simple. It's locally, since no one else can access that machine. And using Proxmox, I'm able to set up. I have set up several virtual machines. So I currently just have this one node named Dash, and on the node I have this machine. This is a simple Ubuntu that I am running. I'm running Ubuntu Live Server. It's my server. It's where I develop and test new web application ideas. This is where I draw my raps at. This is where I run hacking web application from. This is a Parrot OS, Parrot Security OS Edition VM, and I deleted these ones. They are not active. So I mainly use these ones, but mostly concentrate on this. This is where I run most of I would say my virtualization, that my Dockers, my local web servers. I learn them from the web server. Excuse. So once you have set up Proxmox and you have set up your web server for virtualization, now you can start launching and running your own apps and web applications. You can create them. For example, today we'll be looking at a Spring Boot application and we'll be exploring the bug of information disclosure. So the first thing, so I have this application running and the root doesn't have anything. So we receive this generic error. For those, the only endpoint that I currently have is this one, hello. It returns hello world. So this is the error we get. So what I do when I find an error like this uh, is I search on Google so that I can know if it's a new application, an application I have never used. I search on Google. So we search and we go to the first page, and we can see that this guy was using Spring. So we have an idea. Uh, then we read and read and we realize this application is running Spring Boot. So to be able to hack the application, since uh, we need to we are on a 404 error page, meaning there is no application running on the root. We need to find something to hack. We need something to find to hack on. So let's go to Babsite and history. Where I start like, let's use the target. Here is the IP. So send this to repeater. So the first thing we do is try to enumerate the web application. So here we have used this error and we have found that we have a Spring Boot application. So where do you proceed from this? The first thing you can run a generic directory brute force using common.txt or laft. But since we know it's a Spring Boot application, we are able to just go straight to Google and maybe check for Secrist. Secrist Spring, and we get this one. There's a Spring Boot master at the uh, master branch. So the thing we do is we view this as row, and then we control all and control C, and then in our application we send this to intruder. The payloads, we paste our payloads, we disable URL encoding, and we add a position. So yeah, so we have that, and let's duplicate. There's no duplicate. So from this, we start running our attack. You can use something like FAF or any tool that works for you. So and we can either sort by status or by response size. Let's use status. So and we let the brute force run for a while. And the attack has finished. So depending on the program you are hacking on, you can check how many requests per seconds they require so that you can adjust your tool to either be fast or slower. So I had just let the tool run, and now we can check the results. So we find that there's an endpoint called actuator and it's enabled. When we visit actuator, we find that there are several, there's some type of, it's like an API that is returning some information. And as you can see, there are around 10 to 13 endpoints that can be visited. So we have like health, info, condition, configs, and head dump, mappings, all those. So if this was a if these endpoints weren't in our address, the thing we could do would we would send this to repeater, go to repeater, and send to actuator, and then we would start visiting each endpoint individually. Let's have a main, then children. So we have this beans endpoint, and we can see some configurations. We have some configurations. We have this cache endpoint. Sorry guys, I'm under the weather currently. So this has no, we currently have no cache. We have this health endpoint. And that one just returns up. We have health path, we have info. This doesn't return anything. We have conditions. didn't copy that one. As you can see, it returns some type of data. We have config props, and that one also returns some type of data. So depending on the application, the type of data that is being returned, that's how we proceed to exploit. It's the next step. So we have env. This one sounds juicy, and as you can see, this one returns the all the environment variables that are running on that machine. We can see the path which the web application is running on. So you can imagine if this was currently uh, a production application, you might be able to find keys here. You might be able to find maybe AWS access keys. You might be able to find passwords. You might be able to find a lot of things. As you can see, we have a lot. We have the path, all these environment variables. Basically, it dumped the whole environment variables from the application. You can see I have some SSH running, and you can see that is also pointed here. Basically, this is information disclosure, and it can range from a P3 to a P1 depending on the severity. If maybe there were AWS access keys set in the environment variable, you would use those. Maybe they would have an ARM role. Maybe you would find like most production application have several keys. Maybe there's one that controls S3 buckets. Another one is maybe the administrator keys. Maybe you have a root key, and maybe that one, if this was running maybe in AWS, you can be able to escalate to command injection via AWS SSM. The other thing is Roger. This one for Rogers. As you can see, if they have configured Rogers, you would see them here. But there's this endpoint called head dump. Head dump. Is it? I think head dump. Nope. Let me check that. Head dump. Oh, heap dump, not head dump. Heap dump. And this one endpoint is so sensitive because it just basically dumps the memory, the current memory, and as you can see, it's just this is too large. The message is too large. That's because it dumps the current memory. If for example the env environment returned maybe like access keys that were they had, instead of being the usual access keys, it was just maybe star star star. They were obscured. They were hidden by the actuator. So you can do a heap dump and dump the actual memory. Once you dump the actual memory, you can be able to, from there you are able to grep or explore the memory. You are able to grep and explore the memories, and from the memory you can find hard-coded credentials and a lot of things. And I think there's a blog based on this type of attack that I had read. Is it some kind of next? Is it this one? this guy writes very amazing blogs. You should read them. Which one was it? You should definitely, if you are an aspiring bounty hunter, you should be reading this blog. It's usually very, it has very good information. I will attach the blog down in the description. But basically, they found that they could be able to dump the heap dump from an application, and from there they were able to get it was client secret and client ID, and then they were able to forge authentication into to internal APIs. They also found passwords and URLs to internal hosts. It's a great blog. I will attach it down in the description. So basically, that's how I tend to learn. That's how I tend to learn hacking, by standing up labs and being able to run the application locally. And so this is the application that I'm running. So I just told ChatGPT to draw me a quick application. So as you can see, and then I used ChatGPT to to make sure the application was running. And then let's go and dig into the source code. As you can see, I used ChatGPT to solve the errors. And as you can see, actuator has all 13 endpoints exposed. It had just one endpoint held exposed, but I added a special config that allows all endpoints to be exposed, so that I could show you how that such an attack would work. So here we have it. We can form.xml, and as you can see, this is how it. This is the application. These are the plugins. These are the dependencies that are running. None has code highlights. Yeah, as you can see. So this is basically the application, the pom.xml file, and we have the other one was application. This is the one that is exposing all the management endpoints for actuator. And where was it? We have this dev controller. This is the controller. This one is the one that returns hello world. And we have, what was it? Dev application. Yeah, this is the app. This is what runs the Spring Boot application. So basically, that's how this application works. Anyway, I hope you enjoyed the video, and I guess I'll see you next time. Thank you.